Yeah, it will just make my life easier now when I introduce what we did, because then I have to skip a lot of introductory topics, and it's actually very nice.
Yeah, that was the idea.
Yeah, perfect.
Yeah, so Nestor, take it away.
Okay, perfect. So you tell me if, so you see my screen, right?
Yep, I can.
So, well, first of all, my name is Nestor. I am a software engineer. I've been working in different areas. I live in Switzerland, in Zurich, and I work for the Federal Office of Meteorology here in and climatology in Switzerland. And I would like to show you how we use Zarr, and especially how we integrated Zarr with Postgres, so that we can query the metadata catalog using the database. So first of all, why? So that's our use case. So we have created a product called Gridefix, where we actually have a bunch of endpoints to make grid data available for production systems in order to provide real-time or near real-time data available, and also for development, so all the projects can train their models for post-processing and so on. So that's the main idea behind our product or our project. This is a big overview of all the components that are involved in such journey. So we are event-based, so we have a broker that notifies our system in order to import the data. Then we store the chunks in a Zarr group, in Zarr groups, or in Zarr arrays. In cloud native, everything runs in OpenShift, and we have a bunch of services like to fetch the data and to query the data. To query would be the catalog. And in this small talk, I would like to focus myself, or to show you how we configure the data store in order to use Postgres together with Zarr. So what is motivation? Why do we need that? So we wanted to in the catalog service, we want to have fast queries, and the most important is to have data consistency, so that the metadata or the catalog data is actually on sync with the chunk store. So this is our the Zarr metadata store data model. So in the middle here you see the Zarr Nodes. That's the table that Zarr uses to load the metadata from the database. And then we have two tables that they link to each Zarr node. And in that Zarr node, in those tables, is where the catalog looks up. For example, in order to find arrays that with a specific coordinates, or with a specific variables, or with a specific tags. So we have a bunch of queries in order to find the nodes that we want to load. This is more how the Zarr node table looks like. So here you see that we have different levels of groups. So we have the root level, which is our source ID. Then we have the UUID to identify the arrays. Then for each array we have coordinates, and we can also have timestamps, and for each timestamp a variable. And the leaves are the Zarr arrays. So that those would be for example, the vertical coordinate as highlighted here, or the air temperature. Those are Zarr arrays. And then we have as a Zarr group, we have for example, the arrays that they are also highlighted. Also the Cosmo 1, for example, is a root path. Is also a Zarr group. Here a bit of glue code. So this is mainly the code that makes possible to use Zarr with the Postgres database. We implement a store extending the mutual mapping object, and in the get item and set item, we implement the queries in order to fetch data or store data. And we have the main or the root group, and there we configure the store the metadata store and the chunk store here. And then how to load, for example, using a dask array from Zarr, using our PostgresSQL store as a metadata store would be as simple as the following. So given an array path, so we know already, so we have used our catalog to find the variable and the timestamp and which array ID or which path we want to load. And then we can actually create what we call Gridefix database, it wraps the Zarr root node, and then we can just, with this command here, gdb point root, then we pass the path, and then this is actually a Zarr array. Then we can load such Zarr array using dask from Zarr method, and then we have, so we just show here that we get the same shape, so it's the same array. Okay, so I also posted here, or I actually printed out some Jupyter notebook screenshots. Here I use our service, so we have a bunch of API services or REST services to query our database or our metadata. And here, for example, for a given source, I fetch the first variable, actually one of the variables. In this case, is the mass content of water in soil, and then I fetch the tags. So we tag each array in order to for example, if we are going to use that array for a specific thing, then it comes with a tag. So we can tag it, and then we can query for such tags. And then, given that variable and that tags, the list of tags, I just fetch the first one of the available timestamps. That will be this query here. Then here is how we load the arrays. So we use xarray, it was also previously mentioned. We open dataset and we use OpenDAP protocol in order to stream the data. So behind our service, we use dask to load the Zarr array and then stream the blocks to the client. In this case, this open dataset will then call the endpoint. So xarray also supports the OpenDAP protocol, and then at the end we get such dataset. This is that will be also the outcome, and we can also plot it. Also using, so yeah, now that the dataset is loaded, then we can actually plot it, and we can do anything we want in such case. And as a summary, using Postgres speeds up the query for the catalog and also any other metadata. Then something that actually that was our origin is that we had some corrupted data because we wanted to, so we had the catalog, let's say, aside of the Zarr chunk store, and we weren't using transactions at the beginning, and that kind of corrupted the data. So with such transaction management, we can actually mitigate that problem. And then we also have a housekeeping service. We clean up some data eventually. And the good thing is that we only need, so the housekeeping only needs to know SQL and the S3 API in order to clean such arrays. So we don't even use Zarr or dask to clean the data up. So we just know, okay, here, those nodes, they have to disappear. So it's actually very simple. And that could be the end of it.